Ever wonder how two particles can be inextricably linked regardless of their distance apart? Welcome to the mind-bending world of quantum entanglement. This phenomenon, as peculiar as it is intriguing, is a cornerstone of quantum physics. It's a concept that's sparked countless debates, fueled scientific curiosity, and challenged our understanding of the very nature of reality. Imagine two particles light years apart, yet behaving as if they're two sides of the same coin. Change the state of one, and the other responds instantly, as if aware of its twin's fate. This isn't the stuff of science fiction, but a real, albeit strange, aspect of our universe. Quantum entanglement defies our everyday intuition, sidestepping the confines of space and time in a dance that's as mysterious as it is fascinating. It's a testament to the fact that there's still so much about our universe that we've yet to unravel. So let's dive deeper to understand this fascinating phenomenon. Quantum entanglement wasn't born out of thin air. It's a product of the quantum mechanics theory. Let's take a step back to the early 20th century when classical physics was reaching its limitations. Scientists were perplexed by the behavior of light and the atomic world, both of which defied the laws of physics as they knew them. The need for a new theory was imminent, and thus, quantum mechanics was born out of this necessity. Quantum mechanics was revolutionary. It shook the foundations of our understanding of nature. It proposed that particles could exist in multiple states simultaneously, and that the act of observing can change the properties of these particles. Strange, isn't it? But it gets even stranger with quantum entanglement. Quantum entanglement was a concept that even Albert Einstein, one of the pioneers of quantum mechanics, found troubling. He famously referred to it as spooky action at a distance. However, despite its seemingly eerie nature, quantum entanglement is a fundamental aspect of quantum mechanics. It describes the phenomenon where two or more particles become linked and instantaneously affect each other's state, regardless of the distance separating them. This entanglement is born when particles interact and their quantum states become intertwined. For instance, if two particles are entangled and you measure the state of one, you instantly know the state of the other, no matter how far apart they are. Quantum entanglement challenged the very nature of reality, suggesting a deep interconnectedness in the universe that transcends space and time. It was a concept that was initially met with skepticism, but over time numerous experiments have confirmed its existence. In the world of the tiny, the quantum world, particles are not independent entities, but are profoundly interconnected. They dance in a cosmic ballet, their movements intricately choreographed in a way that defies our everyday understanding. Quantum entanglement, therefore, is an inherent part of the quantum world. We cannot discuss quantum mechanics without addressing entanglement. It's a testament to the strange, bewildering, and yet profoundly beautiful nature of the universe we inhabit. Now, how exactly does quantum entanglement work, you may ask? Let's dive in. To understand the mechanics of quantum entanglement, imagine two particles born at the same time. These particles are like twins who, despite being separated at birth, somehow always know what the other is doing. This spooky action at a distance, as Einstein once called it, is the essence of quantum entanglement. When two particles become entangled, they're forever bound by an invisible quantum link. Like two dancers in a perfectly choreographed ballet, each particle takes on properties that are dependent on the state of the other, no matter the distance between them. But how do particles become entangled in the first place? Well, it usually happens when they interact in some way. For instance, if two photons are produced by the same atom, they can become entangled. This means that the state of one photon is directly connected to the state of the other. Now, the interesting part is what happens when we measure one of these entangled particles. The act of measurement forces the particle to choose a state. And the moment this happens, its entangled partner, no matter how far away, instantly adopts a corresponding state. If you're thinking this sounds like magic, well, you're not alone. Even the most brilliant minds in physics have struggled to grasp this bizarre phenomenon. But the fact is, multiple experiments have confirmed the reality of quantum entanglement time and again. It's important to note, however, that this doesn't mean information travels faster than light. Quantum entanglement is not about transmitting information, but rather about the strange correlations that exist between entangled particles. So what does all this mean? In essence, entangled particles are like two sides of the same coin. They're intrinsically linked, each one instantly reflecting the state of the other. This is the heart of quantum entanglement. It may be strange, it may be counterintuitive, but it's a fundamental part of our universe. And understanding it is key to unlocking the mysteries of quantum mechanics. In essence, entangled particles are like two sides of the same coin. What role does superposition play in quantum entanglement? This question brings us to the heart of the matter, to the intriguing dance between superposition and quantum entanglement. In the realm of quantum mechanics, superposition is the concept that a particle can exist in several states at once. Imagine a coin spinning in the air. While it's in motion, you can't tell if it's heads or tails. It's essentially both. That's superposition. The coin only becomes heads or tails when it lands the moment we observe it. Similarly, a quantum particle remains in multiple states until it's measured. Now, let's bring in quantum entanglement. Entanglement happens when a pair or group of particles interact in ways that the state of each particle cannot be described independently of the others, no matter the distance separating them. But how does superposition enable quantum entanglement? Well, when two particles are in a state of superposition and become entangled, the state of one instantly influences the state of the other. Let's say two entangled particles are in a state of superposition. If we measure one and find it spinning clockwise, the other one, no matter how far away, will immediately be spinning counterclockwise. It's as if the two particles are communicating faster than the speed of light. This spooky action at a distance, as Einstein famously called it, relies on superposition. Without superposition, the particles would have definite states before measurement. There would be no room for that instantaneous change, that connection that defies space and time. In essence, superposition and quantum entanglement are two sides of the same coin, or rather, two spins of the same particle. They're both fundamental concepts in quantum mechanics that challenge our understanding of reality. They show us a world that is not fixed and definite, but one that is fluid, interconnected, and full of possibilities. So in answering our initial question, what role does superposition play in quantum entanglement? We find that the answer is quite profound. Without superposition, quantum entanglement wouldn't exist. Quantum entanglement is not just a theoretical concept, it has far-reaching implications. Imagine a world where information can be transmitted instantaneously, regardless of distance. A world where our current understanding of computer processing is blown out of the water. This is not the realm of science fiction, but the practical potential of quantum entanglement. Quantum entanglement can have significant implications for quantum computing. Traditional computers use bits, which can be either 0 or 1. Quantum computers, on the other hand, use quantum bits or qubits, which, thanks to the principle of superposition, can be both 0 and 1 at the same time. Now add entanglement to the mix, and we have a situation where the state of one qubit can instantly affect the state of another, no matter how far apart. This could potentially lead to computers that are exponentially more powerful than anything we have today. But the implications of quantum entanglement don't stop at computing. It could also revolutionize communication. Quantum entanglement could potentially enable quantum teleportation, the instantaneous transfer of quantum states from one location to another. While this doesn't mean we'll be beaming ourselves to Mars anytime soon, it could mean the development of communication technologies that are faster and more secure than anything currently available. There's also the potential for quantum entanglement to impact cryptography. Entangled particles could be used to create a key for encrypting and decrypting messages. If anyone tries to eavesdrop on the key, the entangled state would be disturbed and the intrusion would be immediately noticeable. Quantum entanglement also has implications for our understanding of the universe. It challenges the locality principle, which states that an object is only directly influenced by its immediate surroundings. This could lead us to rethink some of the fundamental principles of physics. Quantum entanglement, thus, holds the key to the future of technology. It's a concept that has the potential to reshape our world, opening up new possibilities in computing, communication, and our understanding of the universe itself. The quantum realm may seem strange and counterintuitive, but its implications are too significant to ignore. Quantum entanglement, a product of the quantum world, remains one of the most fascinating phenomena in physics. It's a concept that defies our everyday understanding of reality, challenging us to expand our knowledge and explore the very fabric of the universe. From its inception, quantum entanglement has intrigued and baffled the greatest scientific minds, revealing a world where particles, no matter how distant, are mysteriously interconnected. Throughout our discussion, we've delved deep into the mechanics of quantum entanglement, touched on the principle of superposition, and pondered the far-reaching implications of this puzzling principle. We've seen how it could revolutionize communication, computing, and even our understanding of the cosmos. Despite its complexities, one thing is clear: the quantum world is an ocean of potential waiting to be tapped. And with that, we conclude our journey into the entangled world of quantum mechanics. Remember, the quantum world is full of surprises, and quantum entanglement is just one of them.